Good evening, everyone. I hope all of you can hear me. So today we are going to start off with the shortcuts on syllogisms. And good evening, everyone. And I hope that basics of syllogism are clear to everyone. So I'm going to share my screen now. If you all can hear me and see my screen, please do drop in a thumbs up. So in the class on deductive logic shortcuts, we will be focusing on how you can get your answers in deductive logic without using a lot of diagrams by just looking at the question. So I will skip the basics, but I will spend time on this syllogism over here. And clarify a couple of things. All right. So a valid syllogism in deductive logic is one where you can deduce the last statement by using the first two. So if you see this, this is the first statement. This is the second statement. And this can be deduced by combining these two statements. Right? Now, when you have these two statements over here, in deductive logic, a valid argument is one that uses and combines the first two statements. So we will jump to the rules of the first two statements. What is it that guides the combination of these two statements and how we come out with the conclusion? Now, in a deductive logic, we see whether the given statements are valid or not, and a valid set of statements is known as a valid syllogism. It is known as a valid syllogism. Right? So first, let's go to the rules of a valid syllogism and understand what these rules are. Now, just any set of syllogisms will not become a valid syllogism. For example, three statements are given over here, and three statements are given over here. So I want you all to tell me which is the valid syllogism in these two. Which is a valid syllogism in these two? Just any set of three statements versus a valid syllogism. This difference is very important. Do you notice that in these three and in these three, how do we know which is a valid syllogism? Let's look at the variables. We have 1, 2, 3 variables here. So let's mark fish as 1, gills as 2, and starfish as 3. Again, we are using fish here. Let's mark it as 1. And we are using starfish and gills in the conclusion. So in the first two statements, how many have we used? We have used 1, 2, 3, and one term has been used twice. The term which is used twice is known as a middle term. And then the middle term gets removed and the conclusion is drawn on the other two terms. I repeat, when we are dealing with a valid syllogism, we have three statements: statement 1, statement 2, and the statement conclusion. In statement 1 and 2, we have used 3 terms and one term has been used twice. The term which is used twice is known as a middle term. This term does not get used in the conclusion. Right? Look at these 3 statements now. We have statement 1, term 1, term 2, term 3, right? Term 2. But look at the conclusion. We have introduced a new term 4 and we have repeated the term 2. What is the rule? That there should only be 3 terms. One term is the middle term and the other 2 terms we use in the conclusion. But in this, we have used 4 terms. Hence, this is not a valid syllogism. Right? So if the middle term is clear, please give me a thumbs up. And then we will look at the next set of questions. So let's look at these 3 statements here. This is statement 1. This is statement 2. And this is the conclusion. Statement 1, statement 2, and this is a conclusion. Now look at this term. This is term 1. Arrest people is term 2. And police officer is term 3. Right? Only police officers arrest people can be written as all people are arrested by police officers. So what is the middle term here? What is the middle term here? We have Terry as term 1, arrest people as term 2, right? And arrest people, term 2 has been repeated here. And police officer, which is term 3, right? So what is the middle term? Arrest people. We remove arrest people. Are we drawing the conclusion between term 1 and term 3? Right? We are drawing a conclusion between term 1 and term 3. So this is also a valid syllogism. So what we learn from here is that in a valid syllogism, you have 3 statements using 3 terms. The last statement is the conclusion. And the first two statements have a term repeated between them, which is known as the middle term. Right? So let's write down these rules quickly in order to understand all deductive logic problems. Now, the first set of rules is the construction of a deductive logic statement. Right? In a deductive logic proposition, a proposition is known as a statement. The proposition has a fixed syntax. We all saw that. It has a quantifier, subject, and predicate. So it has a quantifier, subject, verb, and predicate, and the verb usually is an R type. This is the basics. All of you must be abreast of it. So for example, you have a deductive logic syntax written as all S, R, P. Let me just redo that. I don't know, something's wrong with the writing pad. So the syntax is all S, R, P. So you have a quantifier, subject, verb, and predicate. Have you written down these three rules? So these were the rules that I am talking about. So there are three terms in the first two statements. We know that a term is repeated in both the premises. This is known as the middle term. And a middle term is not present in the conclusion. So if the two statements are all SRP and all PRQ, do you notice the three terms over here? 1, 2, 2 is repeated, and 3. Because P is repeated twice, it is known as the middle term. Middle term gets cancelled and the conclusion is drawn between the remaining two terms. So the middle term here is cancelled. The conclusion will be drawn between S and Q. Can you see it, everyone? Once you have noted this, let me know. I'll let it stay here for a few seconds. Now, the middle term is the most important thing that you will do or work with in your syllogism shortcuts. It is the most important thing that we are going to use in syllogism shortcuts. Once you have written it down, let me know and say that you have noted it. Now, let's quickly understand if you have understood the concept of the middle term. And then we will come back to this. So I'm going to give you some questions to understand whether you know or understand what the middle term is. So I'm going to write down some deductive logic premises sorry. So your job here is to mark the middle term. So give me the middle term in 1, give me the middle term in 2, give me the middle term in 3, like that, quickly. Give me the middle term in 1. We are not going to solve it straight away, because I'm going to tell you how you can just look at it and solve it by just working with the middle term. Because I'm going to tell you how you're going to look at it and solve it by just looking at the middle term. So, why I'm starting to get the answers? The term which is repeated in both the statements is known as the middle term, right? Which is the term repeated in both the statements. So if we call it 1, 2, 1 is repeated, and this is 3. So the middle term over here is hats, right? The middle term over here is pines. The middle term over here is fairies. The middle term over here is covered. Then number 5, the middle term over here is machine. And number 6, the middle term, that's right, is apples. And the middle term over here is fair. So we have marked the middle term here, everyone. Now everyone is comfortable with the concept of the middle term. Right? You will be able to mark the middle term. Great. Let's go back to the rules in syllogism now. And see what we have to do with this middle term, right? So just note down these rules. And let me show you what they mean through the shortcuts. So for any valid conclusion, the middle term has to be distributed, and this is the first rule and the rule we are going to work with. That is single distribution of the middle term. So first we have to understand what is the meaning of distributed. So I'm going to show you that. Also remember that if a term is distributed in the premises only, then can it be distributed in the conclusion? What that means also I'm going to show you. The meaning of shortcut is that I'm going to be using these rules in a manner that you can look at the syllogistic premises and decide whether the conclusion will follow or not follow. Remember that there are 16 answers available in all combinations of syllogisms. And we are going to see those 16 solutions, which means that you are not going to solve them all over again, because all deductive logic syllogisms have been solved by Aristotle. Nobody has been able to challenge those solutions. So most humbly, I think we should also submit that we will be able to solve them in the same manner as Aristotle. People have given their variations, but so far no one has solved or it in a way that has not been solved before. It is like a maths theorem where the mathematician has already solved and given it to you, and the question paper just gives you numbers in the same theorem and you have to just keep resolving it. So deductive logic is as mathematical as that. So if this is clear to everyone, just give me a thumbs up in the chat box. And I'm going to move the screen to the last 3 rules, and we are going to come back to these rules after the shortcuts, and you will see how we have used all of them. Right? Now we are going to move to the concept of distribution of the middle term. That is the first rule that you have written. So let's go back to that sheet where we found out our middle terms. And just try and understand what is the distribution of the middle term. So let me write out the first rule. What is the meaning of the distribution of the middle term? a middle term is distributed if it is modified by all or no or not. All right. A middle term is distributed if it is modified by all or no or not. That means if a middle term is modified by some, it is not distributed. All right. So let's go back to the middle term. First, underline the middle term. So the first middle term is hats. Hats is modified by all in both the statements. Can you see it? So it is distributed twice. The second middle term is pines. In the first statement, pines is not written with all, but in the second statement, it is written with all. Hence, it is distributed once. Can you see it? Third statement, fairies. It's distributed only once. Fourth statement, covered. It is distributed only once. Can you see it? Now, please write yes in the chat box if you understand what I just did. A middle term is distributed if it is written with all or no or not. Hats is the middle term. It is distributed twice. Pines is distributed once. We just have to see if it is written with all or not. Fairies is distributed once. Covered is distributed once. Right? The middle term over here is machine. It is written with not. So it is distributed once. And here it is written with no, it is distributed once. So it's distributed twice. I'll tell you the meaning of no later. Apples is distributed once. Fair is distributed twice. It is written with all as well as no. Rest are distributed once. If this is clear, give me a thumbs up, everyone. A middle term is distributed, or any term is distributed if it is written with all or no or not. That means terms written with some are not distributed. Anything written with no is distributed. Anything written with not is distributed. Anything written with all is distributed. But written with some, it is not distributed. Right? So this is clear to everyone. Can you see the distribution? Great. So now we can come to the actual rules. Now, I was telling you that we have 5 ways of combining these syllogisms, and we have 16 answers. So let us see these ways of combination and their answers. We can combine an all with an all. Our answer will come out either as an all answer or a some answer, because the rule says two universal affirmatives, which means all and all, will always give an answer which is either all or some. We can combine an all statement with a some statement. This answer will always be some. If there is an answer, it will always be some. We can combine an all statement with a some not statement. This answer will always be some not. This answer will always be some not. We can combine an all with a no. This answer will always be no. Why? Because when you combine affirmative with negative, you always get negative answers. So either your answer will be a no or a some not. Two negatives do not give any answer. So this combination is out. You can write it, but remember that this combination is out. Then we have no, which can combine with a some. This answer will always be some not. Two particulars, a sum and a sum, or a sum and a sum not, will never give you any answer. So this is also gone. So how many combinations are giving me an answer? 1, 2, 3, 4, and 5. That means there are 5 ways that I can write deductive logic and get an answer. Note this down. In which all plus all will always give me either all or a sum. All plus sum will give me a sum. Always. It can never give me all. All plus no will give me a no. All plus sum not will give me a sum not. And no plus sum will also give me a sum not. That means I have one way of getting an all answer, which is by using all plus all. I have one way of getting a sum answer, which is all plus sum. I have 2 ways of getting a sum not answer. What are the 2 ways? All plus sum not or no plus sum. Yes or no? All plus sum not and no plus sum. And I have one way of getting a no answer, which is no plus sum, all plus no. Yes? If this is clear to you all, please say a yes. Now you know which combination is capable of producing what answer. You cannot produce any other answer using these combinations. So if you see 2 alls, you know your answer is likely to be an all and a sum. If there is anything else given in the answer, that's never going to be possible. If you see all and sum combination, you know your answer cannot be all. So remove it. You know your answer cannot be no. 2 affirmatives cannot give you a negative answer. And if you see all and no, you know your answer will always be a negative. Right? Great. Distribution I have already told you. Now let's look at all plus all. When we take all plus all, what is our probable answer? When we take all plus all, what is our probable answer? Probable answer means the answer which is possible. Now, whether it's possible or not, we have to check. I told you that any answer will be possible only when the middle term is distributed, right? Let me just plug in my charger. 1 minute. All right, let's focus on this. For all plus all to give an all answer, the middle term should be written with all. That means it should be distributed. The middle term should be distributed at least once, which means it should be written with all. We have these three terms. What is the middle term? The middle term is the term which is written twice. In statement 1, it's not written with all. But in statement 2, it is written with all. So you remove the middle term, right? And whatever is left is your answer. What is left? All S, R, Q. That means we look at the middle term. It should be written once with all. We see it is written with all. We remove the middle term, and whatever the answer is left becomes the all answer. So the rule all plus all gives all when the middle term is written with all in one statement. Tell me if this is clear, everyone. Write a yes in the chat box. Don't worry, we are going to solve lots of questions like this so that you, after you've understood, you can apply it also. So don't write a yes, give me a thumbs. Okay, write a yes, give me a thumbs up, whatever. Now let's look at another combination which is possible for all plus all. What if the middle term is written with all in both the statements? This is the middle term. In statement 1 also it's written with all, and in statement 2 also it's written with all. That means the middle term is distributed twice. Now, neither is P nor Q written with all. They are not modified by the word all. So I cannot make an all answer because both the alls are used by the middle term. So what is left for P and Q? Nothing. However, it's not as if P and Q are not overlapping at all. When the middle term is written with all in both the statements, the answer changes from all to some, and your answer becomes some PR Q. Remember this. So in all plus all, there are two answers: all answer, some answer. If the middle term is distributed once, answer will be all. If the middle term is distributed twice, answer will be some. Just remember it, children. Right? Now give me a thumbs up. And we go to the final combination of all plus all. In the third combination, we see that the middle term is not distributed. Neither here is it written with all, nor here is it written with all. In this case, all plus all gives you no answer. It can be some QRP or some PRQ. It can be some QRP or some PRQ. Both answers are correct. Some answers can be written either way. All answers cannot be written either way. Now, S and Q cannot be written. There is no distribution available for S and Q. So it's something like this. P, S, Q. So we don't know whether they are disjoint or overlapping. So no answer. So when the middle term is not distributed, no answer. So a quick recap. In all, there are 3 ways to work on the answer. If the middle term is distributed once, the answer will be all. Distributed once means in one statement it should be written with all. Distributed once means in one statement it should be written with all. When the middle term is distributed twice means in both the statements it's written with all. The answer will be a sum answer. The remaining 2 terms will be combined using sum. So here the answer will be some PRQ or some QRP. When the middle term is not distributed at all, then you will get no answer. Have you understood all plus all 3 combinations? If yes, then please do write a yes. And let's solve these together. Mark the middle term. See if it is distributed once or twice or no times. I'll give you 2 to 3 minutes to solve it by using the rules that I have taught you just now. All you have to do is mark the middle term, see if it is distributed once or twice or at no times. If it is distributed once, you will get an all answer. If it is distributed twice, you will get a sum answer. If it is not distributed, you will get no answer. So you have 2 minutes to solve this. 2 to 3 minutes. Okay. So I think we have got lots of answers from here. Let's see how many of you, Sia, Trisha, Nandini, have got correct answers. Let's mark the middle term, step 1, and check the distribution. Middle term is distributed once. Hence, my answer will be all men die. So this is a correct answer if you have got it. Middle term is queens, distributed twice. Hence, my answer will be some crown wearer cape. Some answer. Middle term is wasps, not distributed. Hence, no conclusion. Middle term is chaos, distributed once. Hence, my answer will be all pieces worry. Isn't it? Have you got all pieces worry? Remember, the way it is, you have to write it. If all is with peace, it will remain with peace. If all is with men, it will remain with men. You can't change it. You can't say all worry is peace. I hope you know that. Then, middle term is shines or shiny. It is distributed twice. So my answer will be some gold is silver or some silver is gold. Some answers can be changed. You know, they can be written either ways. Middle term is distributed twice. Hence, my answer will be some that chime, rhyme, or some that rhyme, chime. Middle term is not distributed, hence no conclusion. Middle term is kites, distributed once. Hence, my answer is all sands are flown. All sands are flown. So let me know how many of you got it all correct. Let me know how many of you got it all correct. All right. Great. So have you understood how to do this, everyone? Fifth one is 1, 2, 3, 4, 5. It is the middle term is shines or shiny, isn't it? It is distributed twice. In both the statements, it's written with all. Hence, you will get a some answer. Some gold is silver or some silver is gold. Right? So is this is this a fun method? Is this a good method? You just have to spot the middle term. It's a faster method, yes or no? So then let's move to the next set of combinations. All and some. Now, naturally, in all and some, you only have these two statements, and whatever is written with some cannot be distributed. So you have to ensure that the middle term which in this case is P, is always the subject of all. It has to be written with all. If it is written with all, you will get a sum answer. So you eliminate P, your answer will be some SRQ or some QRS. You can write it both ways. It's very simple. Whatever is written with some doesn't matter. You just have to see that the middle term in the all statement is written with all. It is the subject of all. Right? And when you are, then you eliminate it. Whatever remains, some SRQ or some QRS will be your answer. So this is the simplest of all. Right? Wherever the middle term is not written with all, you don't get an answer. So let's quickly do some questions here. I'll give you 2 minutes. Let's solve them together. Try these questions. Oh, sorry. You can do them orally also. So let's mark the middle term and see. The middle term is kites. It is distributed. What will be my answer? Eliminate the middle term. Some that fly are sky, or some sky are fly. Isn't it? Let's do the next one. The middle term is answers. Right? It is not distributed. It's not written with all. Hence, no conclusion. The middle term is roads. It is written with all, isn't it? Hence, my answer will be some blocked have signs or some signs have blocked. Right? The middle term is Harry. Not distributed, no conclusion. Very good. The middle term is novels. It is distributed. So my answer will be some romances are stories or some stories are romances. All plus some is very simple. Can you give these answers in 5 seconds? Yes, that's correct. All of you have the correct answers. Right? Answers can be given in 5 seconds flat. I hope all of you have got the answers now. Let's move to the next one, all plus no. Now listen carefully. In this, just forget about the no statement. Remember that the middle term should not be written with all. So just now in all plus all and in all plus some, we had to see that the middle term is written with all. Now in all plus no, the middle term should not be written with all. Right? Please repeat what I said if you heard me. Please write down in the chat box, what did I say? In all plus no, forget about the no statement. The middle term should not be written with all. Right now, we were tracking the middle term. So in all plus all and in all plus sum, the middle term has to be written with all. But in all plus no, the middle term should not be written with all. Great. So let's go back to this. I'm ignoring the no statement in this. I just look at the all statement. I know that P is the middle term. It is not written with all. All is here, P is here, or with all, S is written. So if the middle term is not written with all, I will get a no answer, no SRQ, or no answer can also be written no QRS. Just like sum, no can be written in any way. So if the middle term is not written with all, my answer will be a no answer. So what will be the answer? No SRQ or no QRS. I hope you have got it. Now let's see what happens if the middle term is written with all. So let's take a scenario where the middle term is written with all. The middle term is S. We ignore the Q statement, no statement, and we see that the middle term is written with S. Right? In this case, we do not get a no answer. We get a some not answer. Because the middle term is double distributed. Right? So our answer will be some P are not Q. How do we write this answer? The affirmative statement is written with P. P is written with some, and the negative term remains written with no. So we have to write a some not answer. Some dash are not dash. So when the middle term is written with all, I'll get a some not answer. Now I have to see where to write P and where to write Q. Remember, the affirmative statement term is written with some, and the negative statement term is written with not. So in this case, when the middle term is written with all, my answer will be a some not answer. The affirmative term goes with some and the negative term goes with not. Why? Because the middle term is removed. So my answer will be some P are not Q. If you understand this, give me a thumbs up. So in all, there are two cases, a no answer and a some not answer. Give me a thumbs up if you have understood this. And then we will do a set of questions. So I'll give you 2 minutes to solve these questions. All you have to do is look at the middle term. And the all statement. So take 2 minutes and solve this. Great. So I can see that you all have answered. So let's mark the middle term. In this case, the middle term should not be written with all. Media is the middle term. It is not written with all. Hence, I will get a no answer. No news is grapevine, isn't it? And I can see that you all have got this answer. Horses is the middle term. Unfortunately, it's written with all. So we will get a somewhat, some not answer. So let's fill some dash are not dash. So the affirmative term will be written in with some and the negative term will be written with not. And I can see that you have got this answer. Very good. Remember that a some not answer, only top 2% of students get that answer correct. Then cuffs is the middle term. It's written with all. So we will not get a no answer. We will get a some not answer. Some dash are not dash. The affirmative term will come here. Some links are not cages. I can see that you have got this answer also correct, Trisha and others. Again, the middle term is written with all. Let's eliminate it. We will get a some not answer. Some stations are not time pass. Right? Then the middle term is dubious. It is not written with all. Hence, we will get a no answer. No doubts are hunches or no hunches are doubts. So, Nandini, Trisha and Sia, you have no. Sia, your last answer is not correct. But others, all your answers are correct. Very good. Can you see it? Please check your answers. Great. Have you understood this, everyone? Give me a thumbs up if you have. So tell me, is this a good method? You just have to pay attention to the middle term and you have got your answer. So is this a good method, guys? It's definitely worth trying, right? No plus sum is the easiest. You don't have to check any middle term. No plus sum is the easiest. We don't have to check the middle term. Imagine, amazing. We just have to check how to write the answer. Remove the middle term. The affirmative one will be written with some and the negative one will be written with no. That's it. It's the easiest. The affirmative term will be written with some and the negative term will be written with not. No checking anything, just remove the middle term. The sum term will be with some Q are not S. This will always be your answer. Simple. Very quickly solve these, children. Let's solve it together. Step 1. Remove the middle term. Now write the answer. Some minor are not dishonor. Some carts are not cars. Isn't it? What are we doing? the some term goes with some and the negative one goes with not. Right? Do the next two together. So it will be some minor or not dishonor. Don't start with no, Sia. It's some not. It's not some. Very good. And the third one, some ties are not skirts. Right? Some spectacles are not chains. That's correct. Understood this? No plus some is done. Great answering, guys. So the affirmative term is written with some and the negative term is written with not. Right? Simple. Now we come to the last one and the trickiest one, because this rule is a little complicated. So what do we have to do is, in this all plus some not, the rule says that either the middle term should be written with all or with not, but not with both. Right? Either the middle term should be written with all or with not, but not with both. So let's see. So let's see. If I'm writing all S are P, some P are not Q. Middle term is P. Right? Neither is it written with all, nor is it written with not. Hence, it's not distributed. So there will not be any conclusion. For a valid conclusion, either the middle term should be written with all, or it should be written with not, but not with both. In this case, P is neither written with all nor with not, hence there is no conclusion. So just note this down and then we move to the next case. Just note this down and then we move to the next case. Now let's check another case. So there are 4 cases, so just be patient. The middle term is S. It's written with all, right? So it's distributed. That means we can get an answer. Let's remove the middle term. The answer will be some P are not Q. Simple. The affirmative is written with some and the negative is written with negative. So if the middle term is written with all, it's distributed. We remove the middle term. Our answer will be some P are not Q. Right? So see here, affirmative is written with some and negative remains not Q, remains not Q. Right? Give me a thumbs up if the second case is clear. And then we move to the next case. The middle term is P. It's not written with all, but it's written with not. Again, it is distributed. Right? Let's remove the middle term. Now my answer will be some Q are not S. So some Q remains as some Q. All S changes to not S. So my answer is some Q are not S. All right, note this down and remember this, children. The middle term is written with not. It is distributed. Eliminate the middle term. Now in this case, my answer will be some Q. Some Q remains as some Q. All S changes to not S. Some Q are not S. Right? And the last case is when the middle term is written with both all and not. So the middle term is distributed twice. Now we get no conclusion. So remember, there are 4 cases here. When the middle term is not distributed, no conclusion. When the middle term is double distributed, no conclusion. So there are only 2 cases where I get a conclusion, either with all or with not. Right? So just write down this clearly for all the 4 cases and let's then solve some questions. So very carefully mark the middle term. If it is written with all, great. You will get an answer. If it is written with not, you will get an answer. If it is not distributed, neither all nor not, no answer. If it is double distributed, again, no answer. So last set of questions, children. I'll give you 2 to 3 minutes to solve them. All right, so I can see some of the answers coming in. So let's try and mark the middle term. This is written with all, it's distributed, right? So my answer will be some onions are not garlic, right? Some onions are not garlic. That's correct, Nandini and Sia. Second, middle term is not distributed, no conclusion. Third, middle term is distributed, it's written with not, right? We remove the middle term. My answer will be some computers remain as some computers. All laptops will become not laptops, right? That's very good answering, everyone. Then my middle term is distributed twice. No conclusion, isn't it? No, Nandini, that's an incorrect answer. My middle term is distributed twice, hence no conclusion. That's correct, Trisha. Then middle term is distributed, it's written with all. So my answer will be some berries are not strawberries. Some berries are not strawberries, right? Then my middle term is distributed skyways. It is written with not. My answer will be some flyovers no, Nandini, the answer is incorrect. Some remains some, right? Some flyovers are not. All carriers becomes not carriers, isn't it? And my middle term is blankets. It is written with all. It is distributed. So my answer will be some rugs are not softies. Right? Check your answers, everyone. I can see just a couple of answers incorrect in the chat box. Rest of them are correct. Right? Any problem in any question here? Yes, Trisha, that's a correct answer. So just to recapitulate, you can go over this video again and again, children. It's a lovely method. You won't find it anywhere except here. All, there are three cases. All plus some. There is just one way to answer, otherwise no conclusion. All plus no, again, two ways to answer. No plus some is the easiest. Just go ahead, mark the answer. All plus some not has two answers and two no conclusions. So if you practice this method, you can really do deductive logic in a short span of time. So I hope this was helpful, children. And the shortcuts are something that you are going to follow. Right? If you have any concerns, if you want to get in touch with us, please just go over to the link in bio. Thank you so much. It was a lovely lecture. And all of you answered beautifully. So I'll see you with more such shortcuts. Maybe we will take up conditionals or something in the next session.